Hey guys, this is a little video about parabolas, and I'm going to be using the program called Desmos. So go to Google and type in Desmos, D-E-S-M-O-S, and you should get to this here. And we're going to look at the graphing calculator part of it, so click there. Okay, so this is Desmos, and over here on the left you can type in equations. For example, the basic equation for a parabola is y equals x. Now to get a squared, you need to go Shift 6. So Shift 6 will get you to the superscript position, the power position, and I can just type in 2. And that graph should look fairly familiar to you. So that's the graph of a parabola. Now this point right down here, 0, 0, the origin, I've been calling it the most important point. And I guess in a sense it is the most important point because it is the minimum value of that graph, the lowest point. And if this graph represented something like wastage or cost, maybe you want to minimize those things. So I've been calling it the most important point, but its technical name is called the vertex. I think I wrote that in the notes, but if not, I will add it to the notes. Okay, so that most important point is pretty important because we want to be able to move this graph around, and we're always going to be thinking about how it's moving in terms of this most important point. So the first thing we can do with parabolas is move them up and down. We can do that pretty easily by just simply adding a number at the end. So for example, adding 3 lifts the whole parabola up 3. Or if we go ahead and take away 2, it shifts the whole graph down 2. You can see the most important point has been moved down 2 places. Okay, so what about moving it left and right? Well, to move it left and right, we can't just add something on at the end. We actually have to go to the x, wrap it up in brackets, like that. And inside the brackets, we need to add or subtract something. And you might think by adding something it moves it to the right, but let's just see what happens. If I add on 3, then it actually moves back to -3. So inside the brackets, that was my cat. Inside the brackets, we have kind of like an opposite going on. That if we want to move it back to -3, we need to add on 3 inside the brackets. And if we subtract a number, then it moves it forward to +3. So that's a little bit weird, but that's just the way it works. Okay, so we can move it up and down and left and right separately, but we can actually do it together. For example, if we wanted to move it to the right 3, like this graph, and move it up 2, all we need to do is add on a 2 at the end, like that. Okay, so every single time we've been moving this around, we've been moving the entire graph. Well, what happens if we just want to move, what happens if we just want to display part of the graph? That's what the domain is all about. So the domain restricts what x values go into the graph. Let's just go back to our original x squared graph. So here is x squared. Now on Desmos, if you want to put a domain, you need to use these curly brackets. That's these ones right here, like this. And inside here, you need to put a starting value that you'd like the graph to start at, and then ending value you'd like the graph to end at. So looking from left to right, I'm going to start it at -1, and I'm going to end it at 2. Now I need to put something in between those starting values and ending values, and what I need to do is this little less than or equal to. Now I got that by pushing shift then comma, that gives you less than, and then I also pushed equals, which is next to delete, and that gives you less than or equal to. I need an x, and then I need another less than or equal to. Okay, so this full thing here that I've highlighted is called the domain. It starts at -1 and it goes to +2, and you see here the graph here starts at -1, an x value of -1, and it continues to an x value over here of +2. So that's what this does right here. It restricts the values that you put into the graph, so you only have part of the graph, not the full graph. And we can change that. If you want to start at 0, start at 0. If you wanted to start at -2, start at -2. You want to stop at 1, stop at 1. Okay, and you can see here that it starts here at -2 and finishes there at an x value of +1. So that's the parabola and the domain, and we can put everything together. We can shift it around and put a domain on it. Let's have a look at an example of that. So I'm going to move it, for example, 2 places to the right. So remember, it's opposite inside the brackets. So it's a -2 there, even though I'm moving that most important point, the vertex, 2 places to the right. And at the same time, I'm going to lift it up just 1. So now it's been lifted up just 1 point. And I'd also like to put a domain on it, so I'm using those curly brackets. I'm going to start it, I want to start it here, which is above x equals 1. And I want to go less than or equal to x less than or equal to, and I'm going to stop it above 4. Okay, so I'll stop it above 4. And there we go. So it starts here at an x value of 1, and it continues until you get to an x value of 4. So that's parabolas and moving them left and right and up and down and turning them off and turning them on and then turning them off. So that's the domain. There's only one other thing that can complicate this, and that's something called the stretch factor. The stretch factor goes right here, right after the equal sign, and it tells you how stretched in a vertical direction the parabola is. For example, if I put a 2 here, it's made the whole parabola twice as sharp, twice as stretched vertically. And if I put a bigger number, like 3, it stretches it even further still. 10 would be very, very sharp indeed. If I change that number to a smaller number than 1, like 0.5, then it flattens it out, or 0.1 would be very flat indeed, 0.2. So you can see here by changing the number in front, that changes how stretched it is in the vertical direction. What happens if you go less than 0? By the way, 0 is just a flat line. If you go less than 0, it's going to give you a upside down parabola, or an inverted parabola. And you can make it -2, which makes it sharp and inverted, or -3, so sharper still and inverted, or -0.5, and so it's sharp and still pretty flat. And that's all the ingredients there are to parabolas. That's it, done. We have a move up and down, that's this part. We have a move left and right, that's this part. We have a stretch factor, maybe. And if you want to turn the graph on and off, use the domain. Okay, so that's just a quick little video about parabolas. I'll do another one about some of the other graphs we're going to look at as well.